Welcome to The Foundry by Forge College. I'm so glad you're here today. In our track on Ethereum dev stacks and frameworks, we've been working through the course Deploying Smart Contracts with Confidence. And this explainer? Well, it is a huge milestone. We're jumping right into Hardhat deployment scripts in practice. We are finally crossing the bridge from all that abstract theory straight down onto the concrete, highly engineered factory floor of code. So, in our last lesson on sharding strategies and data transfer, we definitely had our heads up in the clouds. Lots of high-level theory. But today, we're playfully leaving that abstract world behind. We're putting on our hard hats, literally, and getting into the gritty, hands-on reality of building a deployment script. It's time to actually turn those concepts into execution. Before we pick up our tools, let's just take a quick glance at today's schematic. We're going to hit 5 things. First, the deployment blueprint. Second, powering the environment. Third, our system's safety valve, which is idempotency. Fourth, automation and outputs. And finally, testing the machinery. Simple enough, right? Let's dive in. All right, section 1, the deployment blueprint, focusing on structure and setup. To build a robust automated deployer, we've got to start with a solid chassis. In our case, that is your physical directory structure. Inside your main Hardhat project folder, you absolutely need a contracts folder for your logic, like a basic simple storage contract, for example. Then you need a scripts folder for your actual deploy script. And, this is absolutely crucial, a brand new deployments directory. This specific folder is where our script is going to permanently save its per network records. Moving right along to section 2, powering the environment using environment variables. To bring this drafted machine to life, we need a secure power source. And we wire that up using a library called .env. Think of this as our parts list. Up top, you've got your RPC URL, right? That's the endpoint connecting us to the actual blockchain. Below that, your private key, obviously essential to authorize your transactions. And finally, an optional target variable that acts as a network override. Now, injecting these values directly from the environment means that automated continuous integration robots can operate this machine securely without ever exposing your secret keys to the public, which is obviously a massive deal.
Section 3. This is where it gets really interesting. Safety, or idempotency, which acts as our safety valve. This brings us to what I think is the most critical part of our entire design, making it an idempotent deployment. I know, it's kind of a heavy word, but it literally just means a script that you can safely run multiple times, and it yields the exact same result without ever duplicating the deployment on-chain. Think of it like a really strict doorman checking a VIP list at a club. If your smart contract is already on the list, already inside, the doorman just blocks the duplicate. This stops you from accidentally deploying the exact same contract twice and burning precious ETH on totally useless gas fees. Because, let's be honest, that's a fantastic way to absolutely ruin your weekend. So how does this safety valve actually operate under the hood? It's a simple logical flow. Step 1, the script checks that local deployments folder we set up earlier. Step 2, it reads the specific JSON record for whatever network you happen to be targeting. And step 3, if the contract address is already sitting in that record, it just skips the deployment completely. If it's missing, it deploys. It's essentially creating a persistent referential record so your script never ever suffers from amnesia. Okay, section 4, automation and outputs. Let's wire up the output hatch. With the safety valve installed, we need to wire up the output hatch for downstream pipelines. Here's the script schematic. First, load your environment variables using .n. Second, check that local record file to ensure idempotency. Third, grab your transaction signers. Fourth, deploy, but, only if you actually need to. And fifth, write the updated record and print out a JSON summary. And actually, mastering these exact modular building blocks is a really core part of the learning programs over at Forge College, because knowing how to build predictable infrastructure like this is exactly what separates a hobbyist from a professional Web3 engineer. Now, I really want you to picture something for a second. Imagine the sheer cold sweat of completely crashing your company's CI pipeline just because a deployment step accidentally triggered a second time. It brings up the ultimate question for us today. What actually happens to our machine if we accidentally run this script twice? Well, instead of a massive pipeline explosion, it just gracefully outputs a beautifully simple JSON object shouting reuse true. Just one line. It gives you the network, the contract name, the existing address, and that extremely crucial reused flag. Downstream CI robots can easily read this output and just proceed with their day perfectly happy without blowing up your entire infrastructure. Finally, Section 5, testing the machine so we can verify our local output.
Look, before we let this script run wild on a public network, we absolutely have to test it locally. First, you'll start a local Hardhat node. Second, execute your deploy script right on that local host. Third, verify your outputs and those exit codes. And I literally cannot emphasize this next point enough. If your script hits an error, it needs to fail fast. You want to deliberately trigger a nonzero exit code so your CI pipeline immediately halts. The absolute last thing you want is for your system to silently keep building on top of a completely broken setup. So here is your ultimate success checklist for a perfectly functioning machine. Number 1, the process exits with a clean code 0. Number 2, a single line JSON is printed out to standard output. Number 3, your record file is successfully updated locally. And number 4, any subsequent runs detect the address and safely skip the deployment. If you tick all 4 of those boxes, your deployment machine is purring like a kitten. Let's leave off with a final provocative thought. Are your deployment scripts actually ready to orchestrate multi-environment automation and CI? Think about how you would scale this foundation we just built to handle parallel deployments across staging and production, because that right there is the true power of idempotent infrastructure. If you're ready to master this as part of the Development of Deployment Scripts module and want to dive into other really fascinating Web3 topics, I highly encourage you to visit forge.college to continue your journey. Keep building, stay curious, and thanks so much for joining me for this explainer.